Hello everyone, welcome back to another skill search video. Today we are going over exponent rules, and basically this video is going to cover all the exponent properties as well as negative and fractional exponents. So let's get into it. First of all, let's clear up the definition of an exponent, which is basically a function that multiplies a number by itself. So like 3 to the fourth is just 3 times 3 times 3 times 3. 3 multiplied by itself 4 times, and 5 squared is 5 times 5. And for terminology, we call x the base and y the exponent in this expression in the middle, and we read it as x to the yth power, and that's just to clear up stuff in the video. And first let's start with zero powers, and anything to the 0th power is always equal to 1, and that includes 0 to the 0th power, which is actually pretty interesting, and you'll see why later in the video. Alright, first we're going to do the product rule, which is probably the most commonly used one, and it states that when you have the same base but different exponents and you multiply together, then you add the exponents. So like algebraically, this would be x to the m times x to the n is equal to x to the m plus n power. And for example, 5 squared times 5 to the 3rd power is equal to 5 to the 2 plus 3, or 5 to the 5th power. And you can kind of see this because 5 squared is 5 times 5, and 5 cubed is 5 times 5 times 5. So essentially, you're just adding the number of 5s you're multiplying together. Alright, now let's do the quotient rule, which is the exact opposite of the product rule, where you divide exponents with the same base. And opposite of addition is subtraction, so now we subtract the exponents. X to the m divided by x to the n is equal to x to the m minus n power. And for example, 5 to the 5th divided by 5 to the 2nd power is equal to 5 to the 3rd power. And again, you can kind of see this just by expanding the exponents. On the numerator, 5 to the 5th is 5 times 5 times 5 times 5 times 5. On the denominator, we just have 5 times 5. And you can see how like the denominator cancels out the numerator, and the number of 5s you have multiplied left is the difference between the exponents. So that's pretty cool. And now we can kind of see why anything to the 0th power is 1, because just take x to the m divided by x to the m. Something divided by itself is obviously equal to 1. And by the quotient rule, it's also equal to x to the m minus m, or x to the 0. And this is true regardless of what m and x are. Alright, now let's do negative exponents. And negative exponents basically means a reciprocal of the positive exponent, or x to the minus m is equal to 1 over x to the positive m. And a quick sketch of why this is true: suppose m is a minus b for whatever a and b, and hence negative m is equal to b minus a. And by the quotient exponent rule, we have x to the m is equal to x to the a divided by x to the b, and x to the negative m is equal to x to the b divided by x to the a. And that is equal to the reciprocal of x to the a over x to the b, which is also the reciprocal of 1 over x to the m. So that's cool. Alright, power rule. And this is basically an exponent to another exponent, and in this case, you multiply the exponents. So like the quantity x to the m to the n power is equal to x to the m times n power. And this is mainly because order of operations, parentheses always comes before exponents. So you have to do everything inside the parentheses before you raise it to the exponent. And again, you can kind of see why with a basic example. 3 squared to the 4th power is equal to 3 times 3 to the 4th power. And that's 3 times 3 multiplied by itself 4 times. And basically we have 2 times 4, or 8 3's being multiplied, so we have to multiply the exponents. Okay, now we're going to do fractional exponents, which is basically root. So x to the 1 over m power is the nth root of x, and x to the n over m power is the nth root of x to the n power. And again, you can kind of show this pretty easily. X to the n over m to the nth power, by the power rule we just learned in the last slide, is just equal to x to the n, so that's pretty cool. And if you just let n equal to 1, it's basically the first equation on this slide. And a few more tricks that are just based on order of operations and other stuff we've learned. Quantity x times y to the n power is equal to x to the n power times y to the n power. Quantity x over y to the n power is equal to x to the n power divided by y to the n power. And quantity x over y to the n power is the reciprocal to the negative power, which is pretty much just restating the definition of the negative exponent. Okay, now let's do a few example problems. If you want to pause the video and try them yourself, go ahead, and yeah. Okay, let's move on now. Hopefully you tried a few. For the first problem, we can still add the exponents even though there are 3 being multiplied. As long as the base is the same, we can always add the exponents. So therefore the answer is just 2 cubed, 2 to the 3 plus 4 plus 5, or 2 to the 12th power, so k is equal to 12. For our second problem, the bases aren't the same in this problem, but you have to remember that 4 is equal to 2 to the second power, so 4 to the 6th power is equal to 2 squared to the 6th power, or 2 to the 12th. And now the equation becomes much easier to work with. 2 to the 12 over 2 to the m is equal to 6. By the quotient rule, we have 12 minus m is equal to 6, and therefore m is equal to 6, and that's our answer. For the third problem, there are many rules applied in this problem. You can apply them in any order you want, and it'll still be correct. First, I'm going to get rid of the negative exponent because positive exponents are a bit easier to work with. So I change it to 7 to the negative 2 divided by 7 squared, all to the second power. And now we'll do the product rule first. You can do the quotient rule. The quotient rule first. If you want, it wouldn't really make a difference. So now we have 7 to the minus 4 over 7 to the 4, and that's equal to 7 to the negative 8. And that is our answer. And for problem 4, this is like a kind of algebra problem you probably see in class more. But a good way to approach this problem is because there are a lot of variables, you can just look at each term separately. So for the integer coefficients, we have 27 divided by 9, that's just 3. For the a terms, we have a to the 6th divided by a squared, or a to the 4th. For the b terms, we have b cubed over b to the 11, which is 1 over b to the 8, or b to the negative 8, but 1 over b to the 8 is a little bit easier to look at. And c over c cubed is 1 over c squared. And now we can multiply all those terms labeled in green, or our quotients, together, and we're left with 3a to the 4th divided by b to the 8th times c to the second power. And then we have to square everything because we haven't done that yet. And so we're left with 9 times a to the 8th power divided by the quantity b to the 16th power times c to the 4th power. And a bonus slide, if you have something funky that looks like 2 to the 2 to the 2 to the 2 to the 2, then you have to start from the top. Like so, 2 squared is 4, so now it's 2 to the 2 to the 2 to the 4. 2 to the 4 is 16, now we're left with 2 to the 2 to the 16. 2 to the 16 is 65,536, and 2 to that number is extremely large. It probably doesn't fit on the slide. That's just a cool topic if you're interested. And that's it for this video. Thanks for watching. If you learned something, leave a like and subscribe. There should be a practice handout in the description if you want more practice problems. And yeah, see you next time.